Hello and welcome to JHEP's revision session on allocation using reduction and the Hungarian algorithm. And also, in other words, is augmentation. So we will be using an AQA paper to answer this question, but Edexcel students can still listen in because I learnt D2 Edexcel's way, but I just did the AQA exam. So this is the time taken for these 5 different people to complete a puzzle. And the main objective for allocation is to allocate people to a different puzzle so that the minimum time could be achieved, okay? You can think of it as like a competition, and you're the manager and you need to allocate 5 different people, 5 different puzzles, and hopefully the cumulative time would be as minimal as possible. So the first question is, by reducing the columns first and then the rows, show that the new table of values is like this. First of all, in Edexcel, I know in the book, sometimes it starts with the rows. In AQA, I think that's the same thing as well. But this time it's asking us to reduce the columns first. You've got to be careful that you've read that. So let's go and reduce the columns first. This is exactly the same table over here. It's just that I've redone it for you. So let's have a look. We are going to reduce the columns first. So let's look at column A. We need to find the number which is the smallest out of these over here, and it is 13. Okay, so now 13, we need to subtract all these numbers from 13. So let's start with P5. Let's start with puzzle 5. 13 minus 13 equals 0. 15 minus 13 equals 2. 14 minus 13 equals 1. 14 minus 13 equals 1. And the last one is 16 minus 13 equals 3. Now if we go back, actually no, don't worry about that. Let's go to the second one. Let's look at the smallest value, which is 12. And now we need to take 12 from every single number over here. So what I usually do, I'll usually put 0 just so I remember which one's the smallest value. So 13 minus 12 is 1, 16, 4, 12, 0, 5, 15, 3, 17, 5. Alright, third one is exactly the same. I'm going to go ahead and complete this, so I will be back. Okay, so I have now reduced all of the columns, and I've just done exactly the same thing that I did with the first row and the first column and the second column. So now I'm going to start reducing the rows. It's quite important that you actually make a very big table, because it is very important to show this table so you can get the M1 mark, the method mark. So the second one, which is to reduce the rows, technically you don't actually no I would stick to it and be sure, be safe. So let's look at the smallest number here, which is 0. So all the numbers here are not going to change, because 3 minus 0 is 3, 1 minus 0, so on and so forth. Let's look at the smallest number here. It's 1. So 1 is going to become 0, and we're going to subtract 1 from everything. That's going to be 3, that's going to be 1, that's going to be 3. I'm going to go ahead and finish it off. So I've now completed all of the rows, and we can see that even though it didn't come here, but it said state what K is, because as you can see, K is missing. So K in this case is 3. Yep, it's 3, and you've got to write that down. You've got to state it. When it says state, it means write it down. So K equals 3. Okay, so that's that question done. The next one is, show that the zeros in the table in part A can be covered with 1 horizontal and 3 vertical lines. 1 horizontal, 3 vertical. So let's go back to, you can use whichever one you want, to be honest. I would use the one that we made, just because it's easier to follow up on. So let's make a line going through columns 1, 2, 3, and put a line going through row 4. Okay, and let's see if we've achieved our objective. 1 horizontal, yep, and 3 vertical. Okay, now the thing is, if you've got less lines than the number of columns or rows, you will need to improve this. You will need to further augmentate it so you can find a better allocation to it. So let's see what the next question asks us to do. Use augmentation to produce a table where 5 lines are required to cover the zeros. So we've got to improve this table because it's not good enough. So there's a little trick. See, this is a revision session. There is a little trick, a little shortcut. What we do, we need to identify the smallest number, which is 1. Okay. Now, there's 2 ways in which you can do it. You can do it the long way, you can do it the short way. I'm going to teach you the short way. The short way is any number which is covered by a line, you do not change unless it has been crossed twice. Then it increases by 1. Okay, it increases by the smallest number. Oops, sorry. It increases by 1. Okay, because that's the smallest number. So the new numbers are 3, 4, and 3. All the rest of the numbers, I have not changed. Okay, they're all the same. Now all the uncovered ones need to decrease by 1. Okay, I'm gonna rewrite this out. So that would become 3, that will become 0, that will become 0, that will become 1, that will become 0, that will become 2, 1, 0. I'm going to rewrite this out so it looks much better than it already looks now. So this is now the improved algorithm. I've just written it out again for it to look much better. And as you can see, we've got a lot more zeros to cover up. So let's try experimenting to see if we could cover up the zeros using 5 lines. So 1, 2, 3, 4, 5. Seeing as it's in every column, it would go through every. We'll have to have 5 lines. So that's been done. I mean, be aware that sometimes you might not get a table where you've got 5 rows and 5 columns. It needs to be the same number of rows as it is columns for you to do the Hungarian algorithm. Okay, that's mainly because one person needs to be allocated to one thing, even if it is something useless. Okay, you still need to find out who you need to kick out, if you want to put it in that analogy. So be careful if that does happen. If you do have like 5 rows and 4 columns, you need to add a dummy of the highest value. But don't worry about that, that's not in this question. But so hence, find all the possible ways of allocating the 5 people to the 5 puzzles so that the total completion time is minimized. So all it's saying is which people have got the zeros. That's all it's saying. That's all the questions are saying. Okay, so I can tell you that I'm just going to delete that table. Okay, we can say that puzzle 1 can be allocated to C, okay, because it's got a 0. Puzzle 2 can be allocated to A. Puzzle 3 can be allocated to B. Puzzle 4 can be allocated to D. And puzzle 5 can be allocated to E, okay? Because those are what have the zeros. Usually, you'd write down the original time it would take. We would do that, but seeing as it asks us for 3 different matchings, we'll do that later. So another one we can do, puzzle 1 can be allocated to E. Puzzle 2 can be allocated to C. Puzzle 3 can be allocated to B. Puzzle 4 can be allocated to D. And puzzle 5 can be allocated to A. And then one more that we've got to write down. Puzzle 1 can be allocated to you can pick again. You can choose one or the other. So I don't know, C. Number 2 will be allocated to D. Yep. Puzzle 3 can be allocated to B. Puzzle 4 can be allocated to E. And puzzle 5 can be allocated to, what else am I missing? A. Okay, and those are our 3 different ways of matching. And these will all give us the minimum time, which we are going to calculate now. So with a different colored pen. So let's just use the last one because it's closer to, yeah. So P1 is C. And C, using our original data, is 15. Yep, it's 15. So we do 15. P2 is D. So P2D, that's 14. And then we just add them all up, like so. And I'll tell you now, okay, pretend that we've got all the original values here. The minimum time would be 68 minutes. And that's that question done. The last one, explain how you would modify the original table if we were used to find the maximum. All you've got to do is to do the biggest number minus X, or minus all these numbers. So in an algebraic way, because that did not make sense, it would be the biggest number minus the elements in the boxes. So say for example, if we wanted to find out the maximum number, the maximum time, we would find the biggest number instead of the smallest number. We do the biggest number, which is 18, I think, and do 18 minus 16, 18 minus 14, 18 minus 14, 18 minus 15. We're doing n minus x, where x is an element in the table. And that is it for allocation.